So in this video, we're going to cover model evaluation, which is the phase after modeling where we evaluate the performance of the model that we have chosen. So from let's say 3 or 4 models that is suited for our analytical problem, we can choose based on the performance. Okay, we can choose which one is the best, and next after this is the deployment of the model. Okay, so how do we measure performance? Okay, basically it has to be a performance that can generalize. Generalize here I've covered in the predictive modeling video, whereby you would want to have a model that is able to correctly predict even unseen data points, because remember, we do the training on the model based on data points that is labeled, and then the model learns from those labeled data. But we want it to be able to also predict data points that the machine, the algorithm has not seen before. So that capability is where the model is known as being able to generalize. Okay. Okay, so when we're thinking about classes, there's always 2 kinds of classes, positive and negative. So how do we know which event should be a positive class, which one should be a negative class? Okay, so always remember this phrase: bad positives and harmless negatives. Okay, let's say we have a case where we want to predict fraud. All right, so fraud itself is a bad event that we human beings or banks do not wish to encounter. That's why we want to predict it beforehand. So this is the interesting class that we want to know more about. Therefore, we should put it as a positive class. A positive class is a class that is worthy of attention or alarm. Okay, or it is considered as interesting. Interesting here, not necessarily as in positive, happy, interesting, but also bad. Okay, bad, interesting, which is something that of our interest that we want to know more. Therefore, usually the positive classes would be things that are bad, like for example cancer detection, cancer prediction, what else, fraud, churn, things that humans or people do not like. So this is where we want to know more about it. Often these bad classes or bad events are very rare. Okay, they are very rare. So these positive classes tend to be smaller in number compared to the negative class, which is harmless, because it's like for example churning. It could be just about 1% out of all of the customers who churns. All of the customers who actually churns. The rest do not churn because they have chosen the telco that they want, that they really want. Okay, so when we are choosing a class, okay, we should always remember, okay, the bad positives and the harmless negatives. Yeah. Okay, our prediction can actually become incorrect. Okay, can be incorrect, whereby, for example, if we have a churn case, somebody who does churn, but we predict it to not be churn, to be loyal, for example. Okay, So there's the cost of actually mispredicting can be different based on what is it that we incorrectly predict. Okay, let's say for example, we predict something. Okay, we predict somebody is a fraud. Okay, meaning it is known as false positive. Okay, we predict this person to be a fraud, but a fraud is a positive class. So but he actually is not a fraud. Okay, is that more costly than if we were to predict somebody not a fraud, which is a negative, okay, but actually he is going to do fraud? Okay, another example would be, for example, we predict a patient to have cancer, which is a positive. Okay, is it more costly as in more damaging, okay, compared to if we were to predict somebody not having cancer, a negative case, a negative class, right? So which one is of a higher cost or more damaging depends on the domain that you are in or that you are dealing with, right? So this is accuracy. Accuracy is one of the measure. It is one of the simplest measures of performance. Okay. So what is accuracy? Accuracy is the number of correct decisions made. Okay, meaning that we predict them to be correct. Okay, and it is actually correct. Okay, therefore it is a true positive and a true negative. Divided by the total decisions made, which is all of the predictions, okay, or all of the data set, all of the training set, okay, which is true positive, false positive, true negative, and false negative. So what are all these TP, TN, FP, FN? Okay, TP stands for true positive, which means that we predict it to be true and it is actually true. So our decision was correct. TN, on the other hand, is true negatives, okay, which means that we predict it to be false and it's actually false. So another correct decision. So accuracy considers or take into account or more interested in, okay, the correct decisions. So what is FP? FP stands for false positives, which means that we predict it to be true, which is a positive. We predict an event to be positive, but it's actually negative. Okay, so it is falsely positive. It is not true positive. Okay, and false negative, we predict it to be negative, but it's actually positive. So here, if we take an example of cancer, for false positive, it means that we predict a patient to have cancer, but actually this person does not have cancer. And for false negative, it means that we predict a patient to not have cancer, but he actually has cancer. So which one is more damaging? To tell somebody that he has cancer but he doesn't? Or to tell somebody he doesn't have cancer but he actually has cancer and going around not getting any treatment, you know, whereas for the false positive, the person may go into depression, may actually start spending money because he thinks he's going to die, or actually spends money on treatments that he doesn't need. Okay, so which one is more damaging, more costly, not only on the patient but also on the hospital? Okay, because once somebody got to know about the real situation, a hospital may get sued. So which error is a hospital or a domain or a hospital, let's say, or a customer is more willing to take or consider is more damaging? Okay, this is a matrix called the confusion matrix, and a lot of people do get confused about this. So confusion matrix is showing about true positive and false negative, true positive, TP, TN, TF, sorry, FP, FN. Okay, so it depends on where, this matrix, the cells, don't memorize this, okay? What you need to do is to take a look at the dimensions here. Sometimes the prediction is on top and actual is here. It flips or the other way around. So take a look at the dimensions here, okay? And only then you know what is inside. Because if, let's say, you have actual is positive, okay, and predicted is a yes, so this is definitely a true positive because it is a good decision, okay? And if it is actually negative and you predict it to be negative, so it's known as true negative. Truly, it is negative, yeah? For false positive, it's more of what you predict, okay? The positive there is what you predict, okay? You predict it to be positive or a yes or a true, okay, or truth and false, okay? But we usually don't use that because we need to use it as the adverb, okay? So we want to see the actual is what? The actual is negative. So this must be falsely positive because you predict it to be positive, but it is falsely positive. And this one is falsely negative because actually it is positive. So, but you predict it to be negative, so it's falsely negative, okay? So entries are counts of correct classifications and counts of errors. So each and one of these, okay, counts the number of predictions and that is correct and incorrect, okay? Okay, so this one is like an example, okay, for you to have a look at. There's also all of these other measurements, okay, known as specificity, precision, okay, recall. Accuracy, okay, is the opposite of accuracy is misclassification rate, okay, because accuracy, remember, it is the number of correct decisions. So therefore its opposite, okay, is the error rate, is the all the errors in the world of, okay? So that's why if you take a look at the formula here, okay, accuracy is TP plus TN, all the truths, okay, all the true, whereas misclassification rate is all the false, right? The denominator is the same. It's the total decisions, right? So in other words, we want to know the portion of correct decisions for accuracy, and for misclassification rate, we want to know the portion of errors or mispredictions or incorrectness that we have predicted. True positive rate, okay, is whereby you want to calculate, okay, all of the correct positives that's been predicted, okay, divided by all of the actual positives, okay, all of the actual positives, be it was mispredicted or not. Okay, so the actual yes here is, if we see here, is 105, coming from, okay, the false negatives. Okay, remember, false negative is because we predicted it to be false, we predicted to be negative, but it is actually a positive class, okay, and okay, added to true positive, which where we predict it to be positive and it is actually positive. So true positive rate is known as sensitivity or recall, where we want to know, okay, from all of the actual positives, how many is it that we predicted it to be correct, to be positive, okay, the portion of our prediction of positive over all of the actual positives, okay, so that is true positive rate.